Yes, good evening to you all once again. Welcome back to another important, beautiful session of our control system subject. Today, I am going to present another important topic, that is, by the way, this is lecture number 17. In this, we are going to see the physical systems, mathematical analysis of, you can write, mathematical analysis physical systems. Physical systems, mathematical analysis of physical systems. Okay, so what is a physical system? What it will have actually? Physical system is nothing but basically as far as our subject is concerned, physical system is nothing but it contains lot of various physical elements that are interconnected to each other in order to express or in order to obtain something given objective. There are many physical elements that are interconnected to each other in order to obtain certain objective. That is what a physical system. So under this physical system, we have two types of variants as far as our subject is concerned. The first one is, by the way, the physical system is nothing but it is a mechanical system. That's what we are going to see as far as our subject is concerned. Your physical system is nothing but it is a mechanical system. So the first variant is mechanical translational system. Mechanical translational system. This is one variant of it, means one type of your physical system. And the second variant is mechanical rotational system. It is mechanical rotational system. These are the two very important variants you will be asked from this subject under this topic. Okay, so under this physical system you have two types of variants, that is mechanical translational system and the second one is mechanical rotational system. Today, I would like to brief you about the mechanical translational system. Today, we will see about the mechanical translational system. After that, we will move for the mechanical rotational system. It is a very important topic. Obviously, you will be asking or you will be asked the questions either in your academics as well as in especially UPSC, IAS examinations also in the descriptive part. Definitely you will expect question from this topic. So follow carefully and definitely you will enjoy this class. Okay. Today just I would like to brief you about a mechanical translational system. Okay. All this is under your physical system only. So now I am going to explain you mechanical translational mechanical translational system. Basically, as far as this mechanical translational system concerned, you will be having three basic fundamental elements are there with respect to this mechanical translational system. It is a mechanical system. It is a mechanical system in which there are three important basic elements that are need to be considered, and these three elements plays a very important role in order to study the behavior of that mechanical translational system. What are those three important elements? The fundamental elements, the basic elements, otherwise, the three basic elements, the three basic elements that are need to be considered under this mechanical translation systems are: the first one is the mass mass of the body, mass of the system, otherwise mass. And the second parameter is that it is it is called as spring. The second one is it is a spring. Mass is normally represented or denoted by the letter capital M, whereas the spring is normally denoted by K, whereas the third element is called dash part. This is called dash part and it is denoted by the letter B. These are the three basic important elements that are associated with this mechanical translational system, and elements plays these three elements plays very important role. Therefore, these are the three basic elements, very important elements under this translational system. The first one is mass element, second one is the spring element, and the third one is the dash part element. Dash part. Okay. So normally mass is correspondence to the weight of the body. So for any given mechanical system, you will be having some weight, and normally the weight will be calculated in the form of mass only. The weight of the body. This mass corresponds to the weight of the body. And the spring. What is the spring? Spring is nothing but the elasticity. The elasticity. Normally, if we apply some force on the given body, okay, if we apply some force on that given body, so there is a small amount of displacement will happens. So that is calculated or that is determined, that will be obtained or can be defined in the form of spring constant or okay, spring constant, or this describes about the elasticity parameter, this one. And the dash part is nothing but that describes about the friction, the viscous friction coefficient. This B is called the viscous friction coefficient. The friction will be there. Normally, whenever you apply some force on the body, and in order to move that body from one place to other place, normally you will have some kind of friction there. Therefore, it is a friction coefficient. This is the basically weight, and this describes about the elasticity nature of the body. And the third one is called as the friction. It describes about the friction. Therefore, these three are the very basic elements that are need to be considered under this translational system. So let us see one by one, and basically I will explain you. And moreover, these three elements, how these can be identified, or how these can be represented for the physical system or for the mechanical translational system, how these elements are associated, how to understand. So this is very simple actually. There is nothing to feel difficult to understand it, and I will explain you for your understanding. Let us see, and before that, what are the other elements, other parameters or other factors which are associated with this mechanical system. Other than these three, we have seen these three, that is mass, and then spring, and then dash part. We have seen these three elements. Other than these three elements, what else are associated? What else? Nothing but what other parameters are associated, or what other parameters to be considered in order to study about this mechanical translational system. So the parameters are the parameters associated with mechanical translational system. What are the parameters? Normally, these are the parameters. The first parameter is the displacement. While solving the problem, you will understand better actually. Right now, just listen and you note down, okay, and just you can remember. So the first parameter is displacement. Normally it is represented by the letter x. First parameter is the displacement, and the second parameter is velocity. The second parameter is velocity, that is represented by v, and further this is nothing but v is equal to, it is dx by dt. Your d by dt of x, nothing but differentiation of your displacement, d by dt of x, or is it not? D by dt of x, nothing but your velocity. And the third parameter is acceleration. Acceleration, nothing but a. This is nothing but, it is nothing but d by dt of v, you can write, or this implies d by dt of, what is v? V is nothing but your dx by dt, that is dx by dt. And finally, what is this? D square x by dt square, is it not? This gives d square x, okay, getting d square x by dt square. That's what your acceleration. These are the three other parameters to be considered. First is the displacement, second is the velocity, third one is the acceleration. These are the three parameters which are associated with our mechanical translation system, other than the earlier three parameters. Those are the mass, spring, and that is the friction, viscous friction coefficient, is it not? So how these are interconnected, how these are, what is the relation between all these parameters? There are certain relations, and those relations are governed by the Newton's second law. Okay, now let us see. So one by one I will explain you how normally, if you consider the first element mass, okay. So now I will explain you the force balance equation, okay. The force balance equation of mass. What is the force balance equation of the mass? For this, just consider there is some body having mass m. Assume that it is connected to some reference point, because always one end is definitely to be connected some reference. This is your reference, this is some reference, this is m, and not definitely you should have some displacement there, and assume that we are applying some force F of t on this mass. This is the ideal mass element, you can say. This is ideal mass element. Ideal. This is called ideal mass element. Ideal mass element. Okay. This is the first element we have discussed, ideal mass element. For this, what is the force balance equation? Force balance is nothing but according to your Newton's second law of force. Okay. What is the Newton's second law? According to what is Newton's second law? As per the Newton's second law, F is equal to m into A. Is it not? F is equal to, this is the applied force. Applied force, m is nothing but the mass, A is the acceleration basically. Therefore, according to the second law of Newton's, so the total force applying on any particular body is equal to 0. The sum of the forces acting on a particular body, otherwise the sum of forces, there could be different kinds of forces. The forces due to some other parameter, the other force may be due to some other parameter, and some other force due to some other parameter. So there are so many types of forces acting on particular body. So the sum of all the forces, if you equate, that should be equal to 0. That is what the Newton's second law states that. So as per this Newton's second law, if you apply that law for this mass element, then if it is, this is the mass, it is one end of the mass is connected to some reference, and this is the applied force F, and this is the displacement. Now if we apply some force F of t on this particular body of having mass m, now this particular body will also oppose with certain forces, opposite force to this applied force F of t. Okay, that's what according to this. So whenever you apply some force on this body, at the same time this body will oppose with which applies certain opposition force, and that force is proportional to acceleration of that body. Acceleration of the body. So to understand this, let us see, is it not clear? So whenever you apply certain force on this particular body, and this body will offers opposite force, and that opposition force is proportional to acceleration of the body. Acceleration is nothing but A. So here let us see F of t. What is F of t? Is applied force. This is what your applied force or input force, you can say. Now this is m is already mass, you know that. X is the displacement, you already know that. And F suffix m, what is F suffix m is nothing but the force applied by the body, by this body of having mass m. Okay, Fm is nothing but the opposing force, otherwise the opposite force, otherwise you can write the opposite force, the opposite force applied by the body, applied by the body. Is it not? So now according to the second law of this Newton's, Fm, whatever this Fm, the opposing body is directly proportional to the acceleration. Acceleration, that is nothing but because this is the basic fundamental I am explaining you, and please you can definitely listen very carefully, and afterwards you feel very enjoy while solving the problem. So what I mean to say is that Fm is directly proportional to acceleration. What is your acceleration? A. This implies Fm. What is Fm? That is the opposing body or the force applied by the body in opposite direction to the applied force. Fm is proportional to, what is A? It is d square x by dt square. Just now we have seen this implies. Now remove this proportional, then Fm is equal to, if you remove this proportionality, add some constant, that constant is nothing but your m. This is d square x by dt square. This is what your Fm. This is what your Fm. Now this Fm is nothing but equal to your applied force. That is nothing but F or applied force is equal to is your Fm also. Fm is equal to m into d square x by dt square. This is what the very important equation you need to remember. This is the force balance equation for the mass element. This is the force balance equation for the mass element. Therefore, we have seen three elements first: mass element, and then spring K dash part B. And after that also the parameters associated we have seen: the displacement, velocity, acceleration. Now you just have a relation, you just observe that the mass is connected with your acceleration. This is what. So applied force is equal to m into d square x by dt square. This is the first equation, or you can represent as very important one. This is very important. Force balance. This is called force balance equation for the mass element. Similarly, now force balance equation for spring. This is spring. The second element is spring. The same force balance equation for spring. Spring element or nothing but K. What normally spring describes about the elasticity. What is elasticity? Elasticity is nothing but so the elastic nature. So it will little bit, it seems to be expanded little bit with the due to application of the applied force. It will be expanded. So that expansion of that body is defined, can be obtained, can be defined in the in terms of spring constant. Normally the spring constant describes about the elasticity. Therefore this is the elasticity parameter. What is the force balance equation for this? So in order to understand the force balance equation of it, let us see. So this is the force balance equation. So in the same way, I just represent the spring like this, and one end is connected to a reference. Okay, this is your reference, let us say, and this is your constant K, is it not? So here you have displacement x, and upon which we are applying some force f of t. Okay, so assume that this particular spring is having negligible mass, negligible friction coefficient. That we have to assume that. So assume that this particular spring, this is what your spring element. This is your spring element. Assume that it has negligible mass, and then negligible friction coefficient. So if you neglect these two, then so if you apply some force upon this spring, then spring will offers opposite force, and that force is directly proportional to the displacement. Okay, that is the relation between these two, is it not? So if you apply some force f of t to this spring, then at the same time spring will offer some opposite force, and that opposite force is directly proportional to the displacement. Okay, how that can be expressed? Now let us see I will explain you. Let f of t here also. Let f of t is your applied force. This is your applied force, and f suffix k, f suffix k is the opposite force. This is the opposite force applied by spring, by spring. However, your k is the displacement. Your k is the displacement. Now, this force f of k is directly proportional to the displacement. F of k is the opposite force which is opposed by the spring to the applied force, and that applied force, I mean this Fk, the force offered by the spring is nothing but Fk is proportional to x. Now this implies if you remove this proportionality constant, you can write that Fk is equal to some k into x. Some k into x. This is what very important thing. Therefore, obviously this Fk is almost all equal to your applied force. Therefore, you can write that F is equal to Fk is equal to k into x. I will write here for you. Okay. So this is almost all your Fk is equal to f of t, or f of t is equal to f of suffix k. This is equal to k into x. This is the force balance equation for the spring element. This is the force balance equation, k into x. F is equal to k into the force balance equation. And sometimes in the problem it will be shown that the spring is connected not to a reference. So one end of the spring is connected to some other object, and the another end is connected to the other object. So between the two ends of the spring connected to opposite to other bodies, then in that case what we will see, in that case, say for example, the both ends of the spring connected to some two different bodies, you can say, then in that case what we will assume that, let us say it is x1 and the other end will have some displacement x2, say for example, in that case, because sometimes the spring is connected between two bodies. Okay, so here is one body will be there, another body will be there. Then in this case, what is the force balance equation for the spring? Nothing wrong, the same concept what we have seen, this same here also same concept. So for this f of t, for the application of this f of t, k spring offers opposite force, same we have seen fk, that is the fk is the force offered by the spring or opposition force is proportional to same your displacement x, and this implies here x is nothing but, yeah, it is the difference of the displacement, you can say x1 minus x2, that's all. You have to consider this for this case. Okay, if both ends of the spring, if it has two different types of displacements x1 and then x2, then the force which is offered by the spring is proportional to difference of the displacement, that is x1 minus x2. And finally you can write here f of k, remove this proportionality, then write k, then k into x1 minus x2. Therefore, that is now obviously equal to your f only, the applied force only, that is nothing but your f of t, your f of t is equal to f of k is equal to, what is that, k into x1 minus x2. This is the force balance equation whenever the k has two types of displacement x1 and then x2. This is the force balance equation if it has two types of two displacements, or if it has only one displacement, simply write that k into x, k into x, that is the force balance equation for spring. And now coming to the third parameter, that is the dash part. Okay, force balance equation, third element is the dash part, or viscous friction coefficient, that is called force balance equation of dash pot, nothing but your B. This is called friction, viscous friction coefficient. Normally it is represented by this basically, and it is represented like this. Like this is a piston actually. It is a piston in a cylinder basically. Okay, and say for example one end of the dash pot, this is what your B, this total is called dash pot, and one end of the dash pot is connected to a reference. Let us assume that this is what your reference, this is B, and let us say it is your displacement, it has some displacement. Assume that some f of t is applied upon it, f of t we are applying on this dash pot. Then whenever you apply some f of t, some force on this dash pot, then at the same time the dash pot will also offers the opposite force. That is called, the opposite force is nothing but fb. Here the opposite force is proportional to velocity. What? Velocity. That is nothing but your fb is proportional to, what is velocity normally? It is, what is velocity? Dx by dt. Is it not? fb is equal to your dx by dt. That is nothing but, if you remove the proportionality here, if you remove this proportional, then your fb is equal to, it comes b into dx by dt. Therefore, your fb is almost all equal to your applied force only. F of t is equal to fb is equal to b into dx by dt. This is the force balance equation for your dash pot. This is another very important equation. Therefore, very simple to remember. Whenever you have B, that is called dash pot. So dash pot, whenever it comes, no, B into dx by dt. B into dx by dt you have to remember. So as we have seen in spring case, say for example, here also if the dash pot may have connected between two bodies, then say for example instead of reference, let us assume that it has two displacements x1 and then x2. In that case what you will have? Same. Then what is your fb? Here in this case your fb is proportional to what is there? It is the difference actually. That is nothing but d by dt of x1 minus x2. That's all. D by dt of x1 minus x2. This is equal to fb is equal to b into, it is d by dt of, what is, x1 minus x2. That's all. And finally this fb is all equal to your ft. ft is equal to, fb is equal to b into d by dt of x1 minus x2. The difference of the velocities, d by dt of x1 nothing but the velocity at this point, and d by dt of x2 is nothing but the velocity at this point. Likewise, these are the three fundamental important relations or force balance equations that are need to be considered while solving the problem. So you can expect the questions based on these force balance equations only. Okay, so these are the three important things that are there, not more than this. If you remember these three force balance equations of mass, and then force balance equation of spring, force balance equation of the friction, viscous friction coefficient, if you remember these three formulas, your problem which is on this concept of this mechanical translation system will be easily solved. There is nothing. And moreover, for the given problem on this topic, they will ask you that find out the transfer function. So here, for this mechanical translational system, how to find out the transfer function? Here the transfer function is nothing but since beginning of this our lecture I am continuously telling you that or explaining you that the transfer function is nothing but it is the ratio of the Laplace transformation of output to the Laplace transformation of the input. Laplace transformation of the output by Laplace transformation of the input. So in this mechanical translational system, what is the output and what is the input? The input is f of t. Remember that. So in the mechanical translational system, the input is the applied force is nothing but your f of t. This is your applied force, and the displacement will be considered as the output. Okay, so the displacement will be considered as output, and this is called input. So moreover, in the while solving in this mechanical system, so as we have seen in the closed loop and an open loop control system, so it is nothing but so C of S by R of S. Actually it is C of t and the input is R of t. After application of the Laplace transformation, R of t and C of t will be converted into R of S and C of S. In the same manner, here also you apply the Laplace transformation of f of t, means it is input. Normally for this mechanical translation system, f of t should be considered as input. Then if you apply Laplace transformation to the f of t, so then small f can be converted into capital F and then t converted into f of s. Okay, it is the time domain. Basically this is called the frequency domain. Then it is the conversion from, okay, after application of the Laplace transformation, L of t of f of t becomes f of s, and similarly L of t of your output x of t is nothing but x of s. Capital X it will be converted, however t will be changed as x of s. Now what is input? This is your input, f of s is your input and this is your output. Now tell me, what is the transfer function here? What is the transfer function here? Transfer function is equal to, it is the ratio of output, is it not? Output by input. Basically what is your output? Output is your x of s. What is input? Your f of s. This is what you will be asked in the examination for the given mechanical translational system. So in the subsequent session or in the continuous presentation, I would explain you definitely the important questions based on this mechanical translation system, and thereby we will obtain the transfer function, that is nothing but x of s by f of s we have to find out. This is very important topic. I think you have enjoyed it, and I with this today's session I am going to complete, and I request you all that so you please comment, don't forget to comment, please don't forget to give your valuable feedback, and please you definitely should, I expect the feedbacks and I mean the comments from you, and definitely if you want to like, you definitely should like, and you can share and you can subscribe to this I mean efficient and effective and efficient electronics for excellence channel of this thing, and so that I will continuously work hard for you to give you the best and efficient and effective I mean subject concepts in easy way of for your growth and for your excellence. Okay, thank you one and all.